Good day, everyone. We are here again, and today I want us to cover organic reactions. So we'll just dive right into it. We've already covered quite extensively the naming of organic compounds, and we've covered also how to name all the other compounds, that is, your haloalkanes, your alcohols, and so on. So I want to talk about reactions on how these actually react with one another. So if you haven't hit the subscribe button, you are too late, man. Okay, you can still do so. Okay. And by the way, please, if you want to get in touch with me, if you've got any questions or any previous past papers that you want me to cover with you, please, you're more than welcome to just reach me on my email. It's mlungisi.m.nkosi@gmail.com. mlungisi.m.nkosi@gmail.com. All right, let's dive into it. Okay, so our first lesson, talking about organic reactions. So the first reaction that I want us to go through is what we call combustion. Now, they like these kind of reactions. Let's take, for instance, if we've got an alkane. So essentially, if you take any of the hydrocarbons, so an alkane plus oxygen. So whenever you react an alkane with oxygen, right, what you get is carbon dioxide and water, right? Just keep that in mind. And by the way, this is when you've got what we call a complete combustion, right? So usually it's in the presence of excess oxygen. All right. If it's not in excess oxygen, so you've got what we call an incomplete combustion, and therefore you get carbon monoxide. But nonetheless, these are the most popular ones. All right. So let's take an example of that. So if we've got, say, for argument's sake, C2H6, okay, so that would be an alkane, okay, plus oxygen. What does it give us? It will give us carbon dioxide plus H2O. Now, the only thing about it is that this is not a balanced reaction. You can see that, right? So now what we want to do is now to learn how to balance them. So let's do that quickly. So I've got two carbons on this side. And remember, when you balance, you only put coefficients, right? So you don't, so that you don't change the structure of that molecule, right? So in this case, I've got C2H6. So I've got two carbons on the left-hand side. How many carbons on the right? I've got one. Okay, so how do I make it 2? So I'm going to say, all right, so let's put a 2 there. Okay, so 2 carbons on the left. Okay, now I've got 2 times 1 carbon on the right, so that's 2 carbons and 2 carbons. So my carbons are right. And then I've got 6 hydrogens on the left-hand side. Can you see that? How many do I have on the right? That's 2, you're right. So in this case, how do I make the right equal to the left? Okay, I'll just multiply that by 3 because 3 H2s will give me 6. So that's 3 times 2, that gives me 6. Okay, so my hydrogens are sorted. Okay, now what are we left with? So 2 carbons, 6 hydrogens, 2 times 3 is 6. Okay, so the only thing that's left now is oxygen. So 2 carbons on this side, okay, and then look at this now. You've got 2 times 2, which is 4, right? So you've got 4 just on this carbon dioxide only, right? So let me just write that down there. Okay, and then you've got 3 times 1, which is 3, right? So in this case, so the number of your oxygens, it's 2 times 2, which is 4, and 3 times 1, which is 3, and 4 plus 3, that gives us 7. Okay, so now I want you to look at this. On this side, I've got 2, and on that side, on the right-hand side, I've got 7. So what do I do? Okay, so I'll simply just say, please, I want you to listen carefully. I'm just going to say 7 over 2, so that's 3.5, right? That's 7 over 2. That's going to be 3.5. Now think about it. 7 over 2 times 2 gives me 7, isn't it? So now the number of oxygens on your left hand side is equal to the number of oxygens on your right hand side. Let me get rid of these guys. Okay, so now 2 carbons, you've got 6 hydrogens. 3 times 2 is 6. 7 over 2 times 2 gives me 7, and then 2 times 2 is 4, and then 3 times 1, that's 3. 4 plus 3 gives us 7. So oxygens are complete. However, in chemistry, we usually don't want our stoichiometric ratios or our coefficients or molar ratios, whatever you want to call them, okay? We don't want them to be in fraction form, right? Or we don't even want them to be decimals, right? So now how do I adjust this? Obviously, I'll multiply in this case by the lowest common denominator, okay? So considering there's a 1 there, there's a 2 there, so my lowest common denominator in this case is going to be 2. So multiply everything by 2. So what will you ultimately have? So say 2 times 1, that's 2 C2H6 plus 7 over 2 times 2. Remember, we said we're multiplying everything by 2, né? So 7 over 2 times 2, that gives us 7. So that's 7O2. And then what does that give us? 2 times 2, that's 4. Okay, so that's 4 carbon dioxide plus 3 times 2 gives me 6. So that's 6 H2O. Okay, so that's a combustion reaction. Okay, so that's how you would do that. By the way, you can do this with alkenes, you can do that with alkynes, just remember. Okay, perhaps maybe we want to take an just another example so that you get the gist of it. Okay, right, so okay, let's take something else. Let's say we are going to take C3H8, right? Okay, so let's say C3H8. Okay, so plus oxygen, so that's a complete combustion, isn't it? So we're going to say, right, so you already know, sorry, what the products are, isn't it? So our products are going to be carbon dioxide, sorry about that. So our products are going to be carbon dioxide plus water. Okay, so in this case, what do we have? Okay, so we start again. So you've got 3 carbons on this side, got only 1 carbon there. So what do? Just simply multiply that by 3. So 3 times 1, that's 3. That's 3 carbons. And then 8 hydrogens, okay? So you're going to say, okay, so the number of hydrogens, that's 8, right? And how many do you have on the right-hand side? You've got 2 hydrogens, right? So how do you make it 8? You just simply multiply that by 4, okay? Right, and then so 3 carbons, 8 hydrogens, 4 times 2 is 8, so that should be fine. Now what we're left with now is the oxygen, right? So we've got 2 on the left hand side, and then 3 times 2, that's going to be 6, and then you've got 4 times 1, which is 4, okay, and then 6 plus 4 gives me 10, right? So in this case, you've got 10 oxygens on the right hand side. How many do you have on the left hand side? You've got 2. How do you make that 10? You just simply multiply that by 5. Okay, see, this one was easier because you didn't have the previous situation where you had one of them being a fraction, right? So now what you want to do is maybe just try one on your own and just see my solution thereafter, right? Okay, maybe let's just take another page. Okay, so suppose we take, let's take petrol, right? So that's C8H18 plus oxygen. By the way, this is the reaction that happens inside the engine of a car. That's going to give us carbon dioxide that comes out the exhaust. By the way, these combustion reactions are exothermic. And what we mean by that is that they always release energy. Okay, so energy is released in the process. Okay, so they're always exothermic, or you can just simply express it as delta H is less than 0. Okay, so these are always exothermic reactions. So please try that on your own, and then afterwards you can just put the solution for me at the bottom as your comment. Okay, right. Just want to see if you guys get it. Right. So now I want us to move on to something else. Okay, I'm going to move that away. So I want us to move to other reactions in organic chemistry. Now, another reaction that we've got two types of substances that we have, okay, in organic chemistry. So we've got what we call, okay, so when we take our hydrocarbons, so hydrocarbons, carbons. Okay, so we've got alkanes, alkenes, and alkynes. But now, with your hydrocarbons, you've got two type of reactions, okay? Or you've got two types of compounds that you have. We have what we call saturated hydrocarbons, okay? Saturated. And we've got what we call unsaturated. Now, with our saturated, unsaturated, okay, so with our saturated hydrocarbons, those are the alkanes. So those are the ones with single bonds only between adjacent carbon atoms, right? So in this case, you've got saturated, which are your alkanes, okay? And then under unsaturated, they either have a double bond or a triple bond. Remember, we are talking about hydrocarbons, right? So that can only mean that we are referring to alkenes, right? So the ones with the double bond, okay, in between carbons, or you're talking about alkynes, okay? And alkynes, obviously, the ones with a triple bond between adjacent carbon atoms, right? So now, type of reactions that occur on those. We say, well, suppose that we've got an alkane and it reacts. Okay, so let's take a simple alkane, and we're going to cause it now to react with a halogen, okay? So let's take a simple halogen again. So we say, well, if we take an alkane and it reacts with a halogen, what type of reaction takes place there, right? First of all, I want you to know that those reactions usually don't occur unless we do something else, and that is we put in UV energy, okay? So it means that they are non-spontaneous reactions, okay? So these are reactions that will not be able to take place on their own, right? So therefore, when you put in UV energy, you force the reaction to kind of take place, but otherwise there wouldn't have been a reaction that takes place. And so what type of reaction occurs there, right? So one of the chlorine atoms will now go and substitute one of your hydrogen atoms there, right? So what you end up with, I want you to please note, so we end up with something like this, okay? And please keep in mind, right? So you end up with something like that, but now remember you still have a chlorine atom there with the hydrogen that came off, so this is plus HCl, okay? Right, and now we call these type of reactions, we say these are substitution reaction. This is a substitution reaction, okay? So saturated hydrocarbons will tend to undergo substitution reaction. So in this case, we call this type of reaction a substitution reaction. Substitution. Okay, for obvious reasons, right? One came off and was replaced by another. Okay, so these are the type of reactions that would tend to take place in alkanes. All right. By the way, they can also ask what type of substitution reaction this is. Okay, so what did we react with? We took an alkane and we reacted it with a halogen. Okay, so this would be halogenation. So this would be a halogenation reaction. Okay, by the way, there's nothing wrong if you wanted to say chlorination, okay, because specifically this time the type of halogen that we used was chlorine, right? And then what happens when we take any of those? Let's take an alkene, right? So what type of reactions do unsaturated hydrocarbons undergo? So let's take another simple one. Okay, so when I take unsaturated compounds, right, so there it is, and I react it, let's do the very same thing. So let's react it with chlorine in this case. Okay, so what type of reaction occurs? Now please, I want you to note, I'm gonna illustrate this with my fingers, right? So imagine a double bond to be something like this. Okay, so when the double bond, so you've got what we call the sigma bond. Okay, that's the first primary bond, that's the strongest one, and then you've got a pi bond, which is a weaker one, so it's this one here. Okay, so when it breaks, okay, I want you to see, so when it breaks, now I've got two fingers that can basically hold on to something else, right? So when a double bond breaks, now here it is, we've got the sigma bond there and we've got the pi bond. Okay, right, not that you need to know their names, right? So what happens? So now by the way, these tend to occur more spontaneously. Okay, so in this case we say, all right, so this is what we have. So note, we broke the double bond. Okay, and now we've got two arms or two hands that are available there, right? Remember, those are the ones that form the second bond. Okay, so those are the two vacancies, if you want to call them that. Right, now what happens? This chlorine, the first atom comes there, okay, and the second one goes there. All right, now we say unsaturated hydrocarbons undergo what we call, in this case, an addition reaction. So this would be addition reaction. Okay, right, and by the way, what type of addition reaction is it? Again, funny enough, it has exactly the same name. You are adding chlorine, so obviously again it would be halogenation. Okay, halogenation, and in particular, by the way, it is chlorination. Okay, so these are the type of reactions that alkanes or alkenes tend to undergo. So you must just note, okay, so alkanes, when they react with halogens, okay, they will undergo substitution reaction. And by the way, please just note that we've got a byproduct, and then alkenes undergo an addition reaction, and in this case there was nothing that was formed there. Okay, just to remind you, okay, so what would we name that? Okay, this would be 1,2 dichloroethane. Can you see? So we moved it from being unsaturated now to being saturated. Okay, so that's another addition reaction. By the way, there are other types of addition reactions that may occur, right? Let me just show you those quickly. Okay, so what are the other addition reactions that we can have? Okay, So we can have a situation where we take an unsaturated hydrocarbon, okay. All right, let's take that ethane, ethene again, right? So it undergoes a reaction, right? So now let me react it with hydrogen, okay? So what am I doing? I'm moving it from being unsaturated to being saturated, okay? So what happens? That double bond breaks there, the second bond, the pi bond, okay? And so what happens when it breaks? Okay, so we had that, and then remember the double bond, the second bond broke, and then now we've got two arms that are available, isn't it? One arm there and one arm there. And what happens? So those hydrogens simply just go and attach themselves right there, okay? Right, and then so we moved this reaction from being an unsaturated hydrocarbon to being saturated. And what type of reaction is it now? It's still an addition reaction, right? What type of addition reaction is it? It's going to be hydrogenation. We are adding hydrogen, so we call this hydrogenation, okay? Right. Now, just something that I want to show you quickly, all right? A principle or a rule that we call Markovnikov's rule, okay? Right, so let's say for argument's sake, we're going to take just something a little bit different. Okay, so let's take an alkene, unsaturated hydrocarbon. Okay, yeah, let me take something like that. Okay, right, and we're reacting it. All right, I've added an extra there, sorry. Okay, so we are taking, okay, there we go. Right, so that's the proper one. So now we are taking that alkene, and let's now react it with water, H2O, okay? So when you react it with H2O, in fact, let me write it in structural form, okay? So we are reacting it with H2O. Now, what happens is that H2O will break down into two, so OH and OH minus and H plus, right? And so what happens in this case, please, I want you to listen carefully, okay? So now we know we're going to have a substitution reaction. So we've got two possibilities, okay? We know water is going to form H and OH. So the question is, where does the OH go? Do we take the OH and put it, remember, when you go that other side, okay? So there it is, it moves from being unsaturated, okay, and it is now saturated. So we have that. So I'm just putting everything else there, okay. That double bond breaks. Now you've got those two spaces available, right? Now the question is, am I going to put OH here or an H there, so OH and H, or is it going to be the other way around, H and OH, right? Now then we talk about what we call the major product. So we've got two things. We've got a major product and the minor product. What a major product simply is in this type of reaction, most of the molecules that react with water would form a certain type of compound. That's what we call the major product, okay? So now this is where we're going to apply what we call Markovnikov's rule, okay? And what Markovnikov's rule simply says is that in an unsaturated hydrocarbon, if there's a reaction between hydrogen and something else, so it could be hydrogen and a halogen, right? The hydrogen will tend to go to the carbon that has the most number of hydrogens. Now, please, I want you to note what I've just said. So now we are going to have what? H and OH. So Markovnikov's rule says the hydrogen will tend to go to the carbon that has the most number of hydrogens. Now please, I want you to note, so these are the two carbons that we have. How many hydrogens does this one have? It has two that are attached to it. Can you see? Right? And then if I look at this, how many carbons does it have? It has only one. So Markovnikov's rule says hydrogen will want to go, the major product will be formed when hydrogen goes to the carbon that has the most number. So this one is 2, this one is 1, so definitely hydrogen will tend to want to go to this one. So now what we have as a product, okay, you'll have, so a major product, this is what we'll call a major product. It means H will go there, okay, go to that first carbon there, and then it means that OH will go to that second carbon there. By the way, this is the one way of forming an alcohol. Can you see that? Right, so what we've done is we've taken an alkene, we've reacted it with water, okay, H2O, and now it has formed an alcohol, albeit it's a secondary alcohol for the major product. So it means that your minor product, therefore, okay, so if the examiner does not specify, you must assume that the product will be the major product, right? So it means that your minor product will be so in this reaction means that your minor product will be the other way around. So H will go there, and then OH will actually go to the first carbon, okay? So most of the molecules actually will form that product there. That's why we call that the major product, okay? Right, so that is what we call Markovnikov's rule, right? Okay, so just note that quickly, right? So we said the hydrogen tends to go to the carbon that has the most number of hydrogens. That is how our major product is formed. And by the way, what type of a reaction is this? Once again, can you see it's an addition reaction, right? We've added something that wasn't there. Okay, nothing was removed. So this is an addition reaction, okay? What type of addition reaction is it? We say this is hydration. Okay, now think about you. Okay, when you are thirsty, what do? You drink water, right? So in this case, what did we do? We reacted this with water, so this is what we call a hydration reaction. Okay, right, so where an alcohol is formed. All right, okay, let's go on to the next one. I want to show you just another application of Markovnikov's rule. Okay, so say for argument's sake, we've got let's take another compound. Okay, all right, let's take something a little bit bigger. Right, so that you don't. Okay, so let's take, suppose we've got butane, right? Okay, so with butane, butene or but1-ene rather, okay, so we're going to react that with hydrogen chloride. Okay, can you see? So it's not a halogen, okay, right? So in this case, it's hydrogen chloride. So what happens? What is going to be the major product in this case? So once again, we're going to apply Markovnikov's rule for the major product. So what happens? So we're just going to simply say, okay, for this one, we have HCl, so it's hydrogen and the chloride ion, right? But what does Markovnikov's rule say? Right, so now this hydrogen there, so double bond breaks, right? And then we've got 2 spaces available, right? So the hydrogen goes to the carbon that has the most number. So hydrogen will go there, and this will be the chloride will go there. So in this case, this will be 2-chlorobutane, right? Whereas this was but-2-ene. I hope that makes perfect sense, ladies and gents. By the way, what type of reaction is it? I'm sure you've got it by now. This is once again an addition reaction, okay? But what type of addition reaction is it, right? So once again, it is what we call, in this case, halogenation. Okay, halogenation. So 2 things reacted there. It was the hydrogen as well as the halogen. Okay, so those are the types of reactions that takes place. Okay, right, very quickly, let's go through another one again. Okay, so we've got another type of reaction that takes place. Okay, and in this case, this is what we call a so we've gone through substitution, we've gone through combustion, we've gone through addition reactions, right? So we take what we call an elimination reaction. Okay, so we do have what we call elimination reaction. Okay, right, so as the word suggests, right, you are eliminating something. Okay, right, so what happens in an elimination reaction? Okay, so you are taking something that wasn't there. Okay, let's just focus this a little bit. Okay, so you are taking something that wasn't there, and you are now removing something that was there. So you've got 2 types that can really happen, or that can really take place. So you can have an alkane that can form an alkene. Okay, so you've eliminated something, or sometimes it can be more than one, so it could be alkenes. Okay, plus another alkane. I'll show you what I mean by that. Okay, plus another alkane. All right, usually something with a shorter chain. Okay, right, so that's what happens in your elimination reaction. Or even at times you may have a situation where you take an alkane, all right, and it forms an alkene, or it forms alkenes, okay, and hydrogen. Right, so that would be a typical situation of an elimination reaction. And by the way, I just want you to note there, okay, you wouldn't necessarily know what products are formed. Okay, all you need to be able to know is apply it in a situation as I'm going to show you just now. So suppose we take something that's simple. Okay, so let's take in fact, you know what, let's do this. So let's take an alkane, and we say we are going to take it through what we call an elimination reaction, right? So undergoes an elimination reaction, and in this case, what happens in that reaction? Okay, we said we can have in fact, you know what, let me just make that a bit longer. Let me just add another hydrogen so that it could make for a more interesting product. Okay, so let's take, this is pentane. Okay, so now one of the products that you can form is, we said, an alkene, right? Please, I want you to note. So we can form an alkene, right, through an elimination reaction. Okay, and what happens. Now, please, I want you to note, how would I know? And usually when they ask you this, they'll say it will form this, and let's say product X. And then they say give the structural formula of product X. Okay? So now what is still missing there? You've got an alkane. We had an alkane with how many carbons? 1, 2, 3, 4, 5, right? So now on the right hand side, how many carbons do we have? 1, 2, 3, right? So how many are missing? 2. So now I know I'm going to have another carbon there, right? And then hydrogens. I would have had, so the number of hydrogens there, that's 3, that's 5, 7, 9, okay? That's 11, sorry, that's 12, right? So now you've got 12 hydrogens. How many did you utilize there? That's 1, 2, 3, 4, 5, 6, okay? So how many are still missing? Okay, right, I'm glad that you're getting it. So you still have 6. So you had 12 this side, you use 6 over there, so it means that you need 6 more. So in this case, going to have something that looks like that. Okay, right, so that's the first type of elimination reaction that you're going to have. Okay, by the way, sometimes they call this process, they call it cracking, right? Cracking. So what's happening in cracking? You're breaking down large compounds. You are now breaking them into smaller ones. Okay. By the way, when they get crude oil, it's a very large organic molecule, but they break it down into smaller ones. Okay. In this case, that's where petrol is formed. That's where jet fuel is formed, and all of that, right? They are smaller compounds. They are more usable. Okay, so another type. Okay, right, so there you go. You've got another reaction there. Let's take, let's put that there. Okay, right, so what else can we form? Right, now we apply a process there called Zaitsev's rule, right? And by the way, this is when you'll apply Zaitsev's rule when you've got hydrogen and something else. But more likely is that hydrogen will tend to be moved or removed from the carbon that has the least number of hydrogens. Okay, so you might form something like this. Okay, you might form something that looks like that with a double bond there. You could have placed the double bond there, it's still the same thing, right? Okay, so it's this kind here that we're talking about. You form an alkene, okay, but your alkene also has, remember we removed 2 hydrogens there, and so this would be H2 there. Okay, right, so in this case you moved the alkene and now you've got H2. Okay, right, now just quickly, just to show you what type of reaction do we call this? All right, so we call this is an elimination reaction once again. All right, but what did I remove? I removed hydrogen. All right, so this would be dehydrogenation. Okay, so when I remove hydrogen, yes, it is an elimination reaction. This is dehydrogenation. Okay, right, I hope that we're still together, right? Okay, just to show you again how to apply that Zaitsev's rule. Okay, so we've got a haloalkane here, and we are trying to make to have an elimination reaction, right? So what are you going to have? Okay, so there are 2 possibilities. We definitely are going to eliminate that chlorine atom there. All right, but the question is, which hydrogen is it going to go with? This one here or this one there? And this is where we are going to apply Zaitsev's rule, right? And Zaitsev's rule simply says, in an elimination reaction, right, the major product will actually have remove hydrogen from the carbon, or will take hydrogen from the carbon that has the least, or that has a lesser number of hydrogens, right? So if I look at this, I know definitely this one is going to go away, right? So let's check how many hydrogens rather does this carbon have? It has 3, right? How many hydrogens does this one have? It has 2. So according to Zaitsev's rule, right, the one that has a lesser number of hydrogens will tend to forfeit its hydrogen. So definitely this one has a lesser number, right? So the major product will have hydrogen. So we'll remove this hydrogen here. We'll remove that chlorine there. Okay. So remember, everything else stays exactly as it is. Okay. Right. So you'll have something that looks like this. Okay. Right. So you could have had that. So obviously in the minor product, you'll have a double bond there between the first and the second carbon, right? But now, please just note, we removed HCl. So in this case, this would be plus HCl, just in case they want you to show the reaction there. All right. So Zaitsev's rule says you take hydrogen from the carbon that has a lesser number of hydrogens. Okay. Right. So I want us to quickly move to other reactions. All right. So we've covered all the likely ones. Oh, by the way, sorry, just the name of this reaction. We know it's an elimination reaction, but what type of elimination is it? We call it dehydrohalogenation. This is dehydrohalogenation. Why? Because you remove the hydrogen as well as a halogen as well, right? Yeah, so you can also do this with alcohols. By the way, you'd apply the same principle. If you've had an H and an OH there, you can remove that H and OH, and that forms H2O on the other side. Okay, right. So I just want to go through just amongst the last lessons, last reactions that I wanted to show you, right? And then, so we're going to take just another reaction. All right, so this is a very popular reaction that I wanted to explain to you and take you through. And by the way, in my previous video, if you want to see the reaction for the formation of esters, please go to the video that I produced before on the naming of organic compound, the second video, and you'll see just how to form esters there, right? In case you think I've forgotten about that one. So this is a very popular one, by the way, with examiners. So what they normally do is they would give you either, so when you look at these two reactions, it's exactly the same thing. But what's the difference between the two? It's just the conditions, right? So the conditions of this one, let's start with this one, and we say, right, what happens when we put a dilute strong base, right? So if I put dilute strong base, which is sodium hydroxide, you can use potassium hydroxide in that case, right? What type of a reaction occurs there? Note, when I use a dilute base, right? So what I then form is an alcohol. So this is another way. So the OH would tend to substitute that halogen there. So I produce an alcohol, right? Notice, what did you remove there? You substituted bromide, right? and you substituted OH in the place of the bromide ion there. So now you are left with Na and Br, so that's going to be your other product there, right? But in this case, when it comes to our organic product, this one is formed. Now please note the condition there is that our sodium hydroxide is dilute, right? But what if I use concentrated sodium hydroxide? And by the way, they normally say at a higher temperature, right? So concentrated sodium hydroxide at high temperature, or in this one they would say it in mild heat, right? So now what happens? Instead of an alcohol forming, now I would have an elimination reaction, right? So I'm going to have an elimination reaction, and I'm going to actually get rid, okay? Yeah, so let me do this. Let me say H, and in this case let's put that there. So what would I have eliminated? H and the Br, and they form that double bond there, the second bond, the pi bond, right? So that's an elimination reaction. And by the way, that hydrogen bromide there would tend to undergo an acid-base reaction with sodium hydroxide. So then you get Na sodium bromide plus H2O, salt and water, right? So just note those two reaction conditions there, okay? So definitely this is an elimination reaction. By the way, they call this hydrolysis, right? So they call this a hydrolysis reaction, okay? Right, so so this would be an elimination reaction. And what did we remove? We removed the hydrogen and the bromide. So in this case, this would be dehydrohalogenation once again. Okay, so those are the reactions. And by the way, the most important reactions on organic chemistry, right? So probably in our next video or in the next ones to come, what I'm going to do is how to answer past exam questions on these. Just remember how to do these reactions, and just know how to do these, and I'll show you rather how to answer past exam questions. Okay, right. As I said, if you have any more questions, you're more than welcome to hit me up on my email. All right, but that is in as far as organic reactions are concerned. I want to leave it here for now. Sharp, sharp.